Hello, everyone. I'm Violet Hansen, Microsoft MVP. Have you ever found yourself struggling to manage application control in Windows, or worried about unauthorized programs running on your system? I know how overwhelming it can be, which is why I created AppControl Manager. This tool makes it simple to whitelist only the applications and files you trust, ensuring everything else is blocked, giving you complete control over your system or the systems you manage. In this section of AppControl Manager, you can create base policies using various templates to suit your needs. For instance, the Allow Microsoft policy permits all apps and files signed with a Microsoft certificate to run on your system. This includes essential components like Windows system files, Microsoft 365 apps, Visual Studio, Intune Agent, PowerShell, the .NET SDK, and more. The default Windows policy is stricter. It limits execution to files that are included by default with the Windows operating system and Microsoft 365 apps. This template is designed with more targeted and precise rules for enhanced control. Another option is the Signed and Reputable policy, which builds on the Allow Microsoft base policy. This template leverages the Microsoft Intelligent Security Graph, ISG, to automatically validate and allow safe, reputable apps and files to run, even if they aren't explicitly added to the policy. Each template provides various options to fine-tune the policy to meet your specific needs. For example, you can use the Audit option to create an Audit Mode policy. In Audit Mode, the policy doesn't block files. It simply generates event logs for any files that would have been blocked if the policy were in enforced mode. In Audit Mode, you can also configure the maximum size of the Code Integrity Operational Log directly from this page. Additional policy options are available, such as enabling script enforcement, requiring EV-signed files, and using test mode, which is ideal for testing a policy before full deployment. This page also allows you to create Microsoft-recommended user mode and kernel mode block rules. These rules are pulled directly from Microsoft's GitHub repositories and automatically converted into an app control policy, streamlining the process for you. You can also view the latest version and release date of the Microsoft-recommended driver block rules right here on this page. If you'd like to learn more about any of the available options, simply click the Guide button at the top of the page. It provides direct access to the GitHub Wiki, where you'll find detailed explanations and additional information. Next, let's explore the Supplemental Policy Creation page. With AppControl Manager, creating a supplemental policy is simple. You can scan specific files or folders to generate a policy. If an application or file is being blocked by application control, use this feature to scan its files or installation directory. This will create a supplemental policy that ensures the application or file runs seamlessly on your system. It's important to note that supplemental policies can only expand the scope of your base policies by allowing additional files or applications. They cannot include block rules. Block rules are exclusive to base policies. This page also includes a feature that lets you create a supplemental policy by scanning certificate files. The generated policy will allow any file signed with the scanned certificate to run on your system. For example, if you've used an internal or public certificate to sign multiple files, instead of allowing each file individually, you can simply scan the certificate. All files signed with that certificate will then be automatically allowed. The next page is the System Information page, where you can get a comprehensive overview of all the deployed app control policies on your system. This includes identifying which policies are base and which are supplemental. Base policies can be recognized by the fact that their base policy ID and policy ID properties are the same. You can also see whether policies are signed or unsigned. Most system policies are signed by Microsoft, making them tamper-proof. You can sign your own policies as well before deployment, ensuring they remain tamper-proof, even against someone with administrator privileges. The data table on this page includes a powerful search function, allowing you to quickly find a deployed policy by typing its name, ID, version, or rule options. You can also sort the policies based on their properties for easier navigation. If you find a policy you're interested in, simply select it and either right-click or tap and hold to access the additional menu. From here, you can copy the entire row of the policy or any of its individual properties. The data is copied to your clipboard, and you can paste it into a text editor, such as Notepad, for further use. The data is well formatted, and you can even select multiple rows to copy at the same time. The policy options give you an idea of what each policy is responsible for. By default, Windows has multiple built-in system policies. Some of them are for Smart App Control, while others are for different purposes, such as the automatic vulnerable drivers block list or the new anti-rollback security mechanism that utilizes AppControl to prevent rollback of important OS files to their previous vulnerable versions. You can also use this page to remove deployed AppControl policies. For unsigned policies, removal is straightforward and doesn't require any additional information. However, if a policy is signed, you'll need both the XML policy file and access to the private key of the certificate used to sign it. This ensures that only authorized users can remove signed policies. All supplemental policies, whether signed or unsigned, can be removed without needing any additional information. It's important to note that removing unsigned AppControl policies does not require a system reboot. However, removing signed policies requires one reboot to fully remove them from the system. You can also view the status of advanced code integrity features on the current system. This information is directly retrieved through Windows API calls and provides additional insights into your system's security and integrity. This page focuses on policy rule options, which are crucial in defining how a policy behaves once deployed on the system. These options are among the most important components of any policy. Here, you can specify whether a policy applies to user mode files or is limited to kernel mode operations, such as the vulnerable drivers block list. You can also determine if a policy requires signing before deployment and configure many other essential options. After selecting the XML file path of the policy you wish to modify, you can customize its rule options by checking the relevant boxes and using the Add or Remove buttons. All changes are applied instantly to the policy. There are also predefined templates available that you can select to apply to your policy. These templates consist of curated policy rule options designed to create specialized policies. Base policy template. This template applies exclusively to base policies. It includes the essential rule options that a secure base policy should contain. Supplemental template. Designed specifically for supplemental policies, this template includes only the rule options suitable for them. Since many rule options don't apply to supplemental policies, using this template automatically removes any incompatible options, ensuring a correct and functional supplemental policy. Base ISG template. This template builds on the base policy template by including all its rule options, plus 2 additional options that enable the use of the Intelligent Security Graph, ISG, for automated authorization of reputable files. Base kernel template. This template modifies a base policy to apply strictly to kernel mode files, such as drivers. It excludes user mode files, creating a policy tailored specifically for moderating kernel mode operations. The simulation page in AppControl Manager lets you simulate an AppControl for business policy deployment. Simply select folders or files along with a policy XML file, and it will show you whether the selected files would be allowed or blocked by your AppControl policy if it were deployed on a system and those files were executed. The simulation provides detailed results for every file involved in the process. You can quickly sort and search the results to categorize and locate files with ease. Do you have an AppControl policy and want to test whether all the files of a program will be permitted by the policy without actually running the program? Use the AppControl simulation feature to find out. This simulation also helps you identify files that aren't explicitly specified in the policy, but are authorized to run due to implicit authorization. Additionally, you can detect files with hash mismatches that won't be permitted by the AppControl engine using signature validation. These mismatched files are often found in tampered or questionable software. This page in AppControl Manager is designed as a practical hub for managing app control on your system. Consider it your centralized solution for effortlessly overseeing your app-related policies and allowing new apps. When you need to install a new application, this page provides an intuitive way to temporarily enable audit mode in your existing base policy. This allows the installation of the app while ensuring the base policy automatically reverts to enforced mode immediately afterward. During audit mode, AppControl Manager captures all relevant code integrity and app locker events, analyzes them, and presents detailed insights in an organized view. You can also navigate to the specific folder paths where the application was installed, enabling the tool to scan and display the contents on a separate page. The compiled data, scanned files, and recorded events are presented for you to review, filter, sort, and manage. Once you're satisfied, you can seamlessly convert these into a single supplemental policy ready for deployment. While much of the process is automated, you remain in full control. With just a few clicks, you can fine-tune and manage your app control policy efficiently. Rest assured, no unauthorized software or malware can make its way into your supplemental policy. Every file and event is accompanied by highly detailed information, eliminating any guesswork and ensuring only trusted elements are included. If something like a power outage occurs during the audit mode phase, on the next reboot, the enforced mode-based policy will be automatically deployed using a scheduled task that acts as a snap-back guarantee. This feature can also detect and create supplemental policy for kernel-protected files, such as the executables of games installed using Xbox app. Make sure you run the game while the base policy is deployed in audit mode so that it can capture those executables. Whenever you need help or aren't sure about a feature or control, you can always click the Guide button at the top of any page for instant access to detailed guidance. Every feature in AppControl Manager is thoroughly documented to ensure you have the information you need. If you still have questions, you can always reach out or ask for support on GitHub. The next page focuses on creating a valid code signing certificate that meets Microsoft's requirements for app control policy signing. This page provides multiple configuration options to tailor the certificate to your specific needs. All keys are generated using the SHA-512 hashing algorithm for security. During the certificate creation process, you'll be prompted to set a password. This password protects the private key of the certificate on your system. If preferred, you can disable the password option and rely on confirmation prompts instead. These prompts or passwords will be required each time the certificate's private key is used to sign a file. Key options. Key size defines the cryptographic strength of the private key encryption, measured in bits. Larger key sizes provide stronger security, but take more time and processing power to generate. The RSA algorithm is used, as others like ECDSA are not yet supported. AppControl currently supports key sizes up to 4,096 bits. Common name, CN, specifies the fully qualified domain name, FQDN, or identifier for which the certificate is issued. Validity determines the certificate's validity period, measured in years, during which it is considered trusted and usable. PFX password is a secure passphrase that encrypts and protects access to the private key and certificate data within the PFX Personal Information Exchange file. For the most secure storage of code signing certificates, it's recommended to use a hardware security module, HSM, or a similar device. Obtaining certificates from regulated or publicly trusted certificate authorities, CAs, also requires using an HSM that complies with Federal Information Processing Standards, FIPS, for secure operations. This page in AppControl Manager allows you to create application control policies directly from local event logs, or EVTX files. It focuses on processing code integrity and app locker event logs to help you build tailored policies. The page includes a data grid with search functionality, sorting options, the ability to remove individual logs, and the option to copy entire rows or individual cells to the clipboard. Use the Scan Logs button to scan your system for appropriate code integrity and app locker events. The results will display only audit and blocked events, as these contain the necessary details to create a supplemental policy. The Create Policy button is a hybrid tool that lets you choose from 3 actions for the selected logs. You can add them to an existing Application Control XML policy file, expanding its coverage. You can also choose a base policy XML file, linking the supplemental policy generated from the event logs to this base policy. Alternatively, you can enter the base policy guide directly, associating the supplemental policy created from the event logs with the specified guide. The AppControl Manager application also allows you to directly convert MDE Advanced Hunting exported logs to AppControl policies in a matter of seconds. Microsoft Defender for Endpoint, MDE, is one of the tools that can be used by enterprises and organizations to develop a trusted application policy and manage it at scale. MDE provides the intelligence and insights needed to create and maintain a robust application control policy through its Advanced Hunting feature. This feature uses KQL Kusto query language to query the data collected by MDE, and using the AppControl Manager, we can turn this actionable data into app control policies. We can then use Intune to deploy these policies to our endpoints. All of these tools are built for scalability. Now let's move on to the deployment page. Here you can select your existing App Control Policy XML files or CIP binary files and deploy them all at once on the current system. The deployment process happens one policy at a time, as multiple policies cannot be deployed simultaneously. You can deploy base, supplemental, or app ID tagging policies using this feature. We can use the System Information page to see that the deployment has been successful. Use this page to calculate code integrity hashes for files. These hashes, used primarily by Windows Code Integrity, include first-page hashes and authenticode hashes, which differ from regular flat file hashes. Authenticode employs cryptographic techniques to verify both publisher identity and code integrity. It combines digital signatures with a trusted infrastructure of certificate authorities, CAs, to assure users that a file or driver originates from its claimed publisher. By chaining the certificate in the digital signature to a trusted root certificate, Authenticode enables users to verify the publisher's identity with confidence. Simply use the Browse button to select a file, and the hashes will be instantly calculated and displayed on the page. This page in AppControl Manager allows you to query secure settings in the deployed policies. AppControl for Business policies include a settings section where policy authors can define custom secure settings. These secure settings provide tamper-free configurations for systems with secure boot and policy signing enabled, ensuring that even local administrators cannot modify them. Each setting is defined by a provider, key, value name, and a corresponding setting value. For example, an application may wish to restrict its own capabilities when running on a system with an active AppControl for Business policy. Application authors can define settings within an AppControl policy that their application queries to disable specific features or enforce stricter controls. The Logs page displays the most recent logs generated during the current AppControl Manager session. You can customize the log display by changing the text color, highlight color, or using the search feature to find specific entries. Various features within AppControl Manager generate logs, keeping you informed about key events and actions as you use the application. The application automatically manages the size of the logs directory. If the logs exceed 100 megabytes, older logs will be overwritten by new ones. The application leverages the operating system's WebView 2 to provide built-in browser capabilities. This ensures you have quick and seamless access to the hardened Windows Security Repository documents and relevant Microsoft documentation directly within the app, eliminating the need to switch to an external browser. In the AppControl Manager's update page, you can configure the app to automatically check for updates at startup. Alternatively, you can manually check for updates or customize the update behavior to use a hardened update procedure for enhanced security. The update experience in the AppControl Manager is a very convenient and non-intrusive experience because when the app is updated, it won't restart itself. Instead, it will wait for you to close it, and the next time you open it, you will be automatically using the new version. Additionally, you can select an MSIX package to install as an update for AppControl Manager. This feature is particularly useful if you've already downloaded the MSIX file from GitHub or built the application from the source code yourself. This method also allows you to downgrade to an earlier version if you ever need to do so. AppControl Manager offers plenty of customization options to suit your preferences. You can choose from different styles of navigation buttons, select various backdrops or backgrounds, and configure a dark or light theme independent of the operating system settings. Additionally, you can enable sound effects to hear audio cues for navigation and interactions within the application. The application also supports Mica, a dynamic, opaque material that blends your desktop wallpaper and theme to create a visually cohesive background. For a more pronounced effect, Mica Alt provides stronger tinting based on your desktop background color. Alternatively, you can opt for the acrylic style, which incorporates greater transparency, adding a sleek and elegant touch to the application's overall appearance. The settings page also allows you to configure and query user settings for the app's operations. These include options like setting the path to your most frequently used signed and unsigned XML policy files, so you won't need to browse for them in different scenarios. You can also define the path to the signtool.exe executable file, which is required for all signing operations. These settings are saved in a JSON file, giving you the ability to back them up or restore them at any time. Now, let's create a default Windows-based policy in audit mode and deploy it on the system. This policy will be used to generate audit logs whenever unauthorized applications attempt to run. We can see that the default Windows policy has been successfully deployed on the system. When deploying any policy from the Create Policy page in AppControl Manager, the application also deploys the Microsoft Recommended Block Rules policy. As mentioned earlier, this is the user mode block list that Microsoft recommends to prevent app control from being bypassed. AppControl Manager ensures there is only one instance of the recommended block rules, so even if you deploy multiple policies, you will only see a single recommended block rules policy in the list. Additionally, for every base policy deployed via the Create Policy page, an AppControl Manager supplemental policy is automatically created and deployed. These supplemental policies allow the AppControl Manager application to run on the system after deployment. Without them, the app itself would be blocked from functioning. When attempting to remove an AppControl Manager supplemental policy, the application verifies whether the associated base policy is still present on the system. If it exists, you will receive a prompt explaining the outcome of the removal process and asking for confirmation. The special AppControl Manager Supplemental Policies XML source is available on GitHub for review. It consists of a single rule that allows the AppControl Manager application to run by specifying its package family name. This ensures that the application remains functional even after updates. Now that we have an audit mode policy in place, let's start a third-party application, such as VLC Media Player. You'll notice that the app launches normally. In the background, however, Windows is logging every file that VLC Media Player executes in the code integrity logs. Each log entry contains detailed information about the file, including its hash, publisher, path, and more. AppControl Manager makes it incredibly efficient to work with these logs. When you press the scan button, you'll see how quickly it indexes the event logs, presenting complete information almost instantly. When creating a policy based on event logs or Microsoft Defender for Endpoint Advanced Hunting logs, there are two rules to keep in mind. If you select specific logs from the data table on the page, only those logs will be included in the policy. If no specific logs are selected, all of the displayed logs will be included. This flexibility allows you to choose exactly the logs you need. Additionally, you can right-click or tap and hold on any displayed log entry to remove it from the data table if necessary, and it will be excluded from the policy file as well. The hybrid Create Policy button provides three options for handling logs. Add to policy. This option allows you to select an existing policy file and add the logs to it. Base policy file. Here, you can choose a base policy XML file. The base policy's ID will be automatically extracted and used as the base policy ID for the new supplemental policy being created. Base policy guide. This option lets you directly enter an ID to be used as the base policy ID for the supplemental policy being created. There are multiple scan levels available to choose from, each tailored to specific needs. The publisher level is ideal for signed files, as it relies on the file's signature to authorize them in the policy. The hash level works for both signed and unsigned files, but can be challenging to maintain. Any changes to the file, such as updates to an application, will require deploying a new supplemental policy to authorize the updated files. The file publisher level considers the file's signature along with attributes like version, original name, product name, internal name, and file description, offering a more comprehensive way to define policy rules. Another way to create supplemental policies is by scanning files or folders, which can be done through the Create Supplemental Policy page. Thanks to the high-performance, precise algorithms and parallel processing used for file indexing and scanning, you can even select the entire OS drive, containing millions of files, and quickly generate a supplemental policy that includes all the files found there. To create a supplemental policy, you'll need to provide a name for it and select a base policy XML file that the supplemental policy will be associated with. All detected and scanned files will be displayed in a data table. You can access this table by clicking or tapping the View Detected File Details bar at the bottom of the section to navigate directly to it. After creating a supplemental policy for the VLC media player by scanning its installation directory, we can perform an app control simulation to verify whether the policy file successfully authorizes all the files in that directory. The simulation process requires selecting the XML policy file and the files or folders to simulate against. In this example, we select our supplemental policy and the VLC media player's installation directory. The simulation results can be exported to a CSV file, which can be opened in Excel or Visual Studio Code for easy viewing and analysis. The simulation also offers scalability, allowing you to control the number of concurrent threads used during the process. Increasing the number of threads speeds up the simulation, but also increases hardware resource usage, making it highly adaptable to your system's capabilities. Use the built-in search bar to quickly locate specific files based on various properties. You can also rearrange columns or sort them to create a more personalized view. Additionally, you can copy entire rows or individual properties from the rows to the clipboard for further use. The simulation feature in AppControl Manager is an excellent way to verify policies before deployment. It helps you identify and resolve potential issues without needing to deploy the policies on the system. The simulation results clearly show which signer or rule in the XML policy is used to authorize each file. It operates just like the code integrity engine in Windows. The results also indicate the authorization level applied to the file, and if the file was created using the file publisher level, it will display which specific file attributes were used to authorize it. Simulation supports all file scan levels, including WHQL levels. So to wrap things up, AppControl Manager is a mature platform that meets all of your needs when it comes to app control in the Windows OS. Whether you're managing millions of devices at scale for enterprises or simply managing your personal system, AppControl Manager has everything you need for robust application control. Security is paramount when selecting any application designed to safeguard your systems. The last thing you want is a security-focused tool that inadvertently expands your attack surface, or one that doesn't prioritize security at its core. AppControl Manager is completely open source, and its source code is fully commented, making it easier for code reviewers to thoroughly assess and verify every section of the code. The AppControl Manager application is built publicly using a GitHub action, which includes artifact attestation and software bill of materials generation to comply with SLSA Level 2 and other security standards. The source code, as well as the MSIX package, is automatically uploaded to VirusTotal. Additionally, GitHub's CodeQL advanced workflow scans the entire repository using an extended security model. AppControl Manager is engineered with a security-first approach from the ground up. Designed specifically for defense teams, it's also rigorously shaped with an awareness of offensive strategies, ensuring resilience against emerging threats. The AppControl Manager doesn't rely on any third-party components or dependencies. All logic is built securely and specifically for this application. On the GitHub wiki page, you'll also find a table that lists every URL AppControl Manager connects to or uses, along with a precise justification for each one. Finally, AppControl Manager supports various exploit protection mechanisms to safeguard itself from external threats. That's all for today's video. I hope you found this content helpful. Don't forget to subscribe to the channel so you won't miss any future updates like this one. Take care, and I'll see you in the next video. Goodbye.